Um, as a game artist, the proof is always in the engine. So if you build something, I don't care what it looks like in Marmoset tool bag. I don't care what it looks like um, in the viewer in Substance Designer. What does it look like in engine? Does it look good in Unity? Does it look good in Unreal? Does it look good in the bespoke engine that you're using? And if it doesn't matter what it looks like in those tools, because that's not how it's going to be seen eventually.
I've worked with Mike for 3 years when I was in New Zealand. Mike has worked in games like Counter Strike, Train Simulator 2, Motocross Madness 2, and various other games. He's been in the industry for over 23 years with 9 years of teaching experience in higher education. So I'm going to hand over the session to Mike, where Mike can answer some of the questions that you asked me in the Discord channel and directly messaged me. Thank you so much. If you want me to bring more guests like Mike, please subscribe to the channel and hit the bell icon so that I can get support from all of you and bring more guests like Mike on the show. Thank you.
Hi, my name's Mike Porter. I'm a professor at SMU Guildhall. Drew and I used to work together at Media Design School in Auckland, New Zealand, where I was the program leader for the Bachelor of Creative Technologies. And I'm really happy to answer some questions for y'all. And so I'll go ahead and start with the list. I'll answer some questions, and if I can show some pieces as well, I'll do that just so we can talk through them. Okay, the first question is, what software to start learning for 3D work in games? I learned in 3D Studio 3D Studio 3, and not even Max. This is prior to Max. But prior to that, on the Amiga, I was learning some software. It was Turbo Silver, which was an old 3D package that was for the Amiga. What I like to say is that I like to be tool agnostic, meaning I just want to know the tools and understand the principles of 3D, and then whatever tools I'm using, those principles will be useful elsewhere. So I've learned 3D Studio Max and Maya, and I'm currently starting to learn Blender, and I've done some work in 3D Code. And each one of those programs are pretty similar. So you just need to know where all the pieces are, like how to create geometry, how to edit the geometry, how to unwrap, things like that. But once you learn those hotkeys and where the location of those tools are within the UI, then it doesn't matter which tool you're using. What I would say is I would recommend starting with Blender because it's free and you can learn. And if you're going through university or a high school, you should be able to also get the Autodesk Education license for free as well, and that'll give you both Max and Maya. But again, what I started on was 3D Studio 3, but I've worked in 3D Studio Max, 3D Studio 3, Maya. I haven't done any professional work in Blender, but I think the way that the industry is going and how many tools have been added to Blender, I think that's going to eventually become an industry standard. So I would start off by learning that, and then hopefully when the time comes, you can just transition into that software. So the next question is, do you prefer Maya or Max? It depends on what I'm doing. So I prefer Max for vehicles and for railing and things like that, architecture of vehicles. But I prefer Maya for props and organic models and things of that nature. I think Maya, again, each tool has its strengths and weaknesses, and again, once you find where the create button is, where the edit button is, then you can pretty much do anything in either one of those tools. But I find that with Max, there's too many button presses to work efficiently sometimes. But there are some really good tools, such as the sweep tool, I like the UV map and the UV unwrap tools in there, but what I like about Maya is that it's hotkey driven, and so I can do a lot of things really quickly, like performing the last action by hitting G, or really quickly changing my pivot point using insert and then alt middle mouse, or middle mouse Z, or middle mouse C, or middle mouse X, middle mouse C, and middle mouse V. V is for vertex, C is for edge, and X is for grid. And those quick hotkeys, and then also, F8, F9, F10, F11 for basically what you would do in 3D Studio Max is right click, convert to editable polygon, and then work on it in that way. With Maya, it's just F8, F9, F10, and F11, and that switches between the different modes: vertex, edge, face, and F8 is just going back to object mode. Okay, the third question was, do you need to know Unity or other game engines as well, or should you just learn Max or Maya? So I think there's real power in understanding how to use the engine. So I think the best way to work is to learn 3D Studio Max or Maya, and then be able to export your model out from that package and put it into a game engine such as Unreal or Unity. Either one of those. And actually, I would just recommend you use both. They're both free. There's hundreds of thousands of man hours of tutorial videos on how to use those things. So why not take advantage of something that's available to you? Learn how to import your model into Unreal, how to set up a shader network, how to apply that, how to set up lightmaps, and the same thing with with Unity as well. Use the same tool set. It's, again, just like 3D Studio Max or Maya. Unity and Unreal have some very similar tool sets, so you might as well use both of them, because once you learn where one is and how it functions, you should be able to do the same in the other one. Okay, question number 4 is, how have you motivated yourself for 23 years? That's a tough one. The problem with being an artist in the game industry is that you have to be creative as a job. It's not just as a hobby anymore. It's not when you feel like it, but it's every day being creative and being focused. So where I find my creativity and where I find my inspiration is from playing other games. It's from looking at other people's art station and seeing the work that they're doing. It's listening to people talk about the games that they're playing, or watching it on Twitch, or whatever it is. I mean, that seeing people play games and understanding how it changes their lives and makes them feel is really, really strong for your inspiration. Looking at other people's work and seeing where they're at. Some people look at the work quality out in the art station and they get frustrated and say, I'll never be that good. But you don't have to be that good. You have to be as good as you can be. And that's where I find my motivation, is I try to be as good as I can. I'm not the best artist. I worked hard at trying to be better than I was before. And so that's what keeps me motivated, is just continually trying to push my creativity and making sure that I'm doing something that's fun and engaging. Okay. Let's see, question number 5 is it possible to make light-baked prefabs in Unity? So there's 2 different things. First of all, if you're using a prefab, you can't bake the light of the prefab until it's in the scene. And the reason why I say that is, let's imagine that you make an object and you pre-bake the light map, and it puts highlights and shadows into the model, and then when you place it in the scene, that means that it's a directional model. You can't rotate it. So the way that you would approach this is that you would just light map unwrap your model, and there's different ways of using it inside of Unity. You have completely dynamic lights. You have mixed, which is dynamic and baked, and then you have baked. And there's different pros and cons to each one of those. But what I would say is that if you unwrap your model for texture, for your UV texture, and then when you import it, there's a little checkbox inside of Unity that you can click to generate UV light maps, so you don't have to do the additional work. That being said, sometimes I think it's better to actually understand how much space you're giving up for something. So, and what I mean by that is let's say I have a house. There's going to be polygons of that house that aren't as visible as other polygons, right? So let's say the wall is one polygon, and then there's a little strip underneath the windowsill that's very small. When you auto-generate light maps, what happens is it just calculates area, and it gives that space as much area as it would in proportion to the wall. But I don't need that much information on there. I just need to know whether it's light or dark. So if I unwrap the light map myself, I can shrink that down really far, and I don't have to worry about it calculating additional information for that. So understanding how to light map, unwrap, and how to work in that way is really essential to making sure that you're getting the best quality results from what you're doing. But what I would say is that sometimes it's easier just to hit that auto unwrap button when you're trying to test things out. So before you understand the process of unwrapping well and understand how the light maps work, that might be the best option. But I do recommend going back and learning how to unwrap properly and understanding that process. So when you do make that model that's going to be put inside of Unity, you have the best quality model you can possibly get. So again, baking prefabs is not the way to go. You light map unwrap, but then when you place it in the scene and generate the lighting bake options, that's when it bakes the light maps. Okay, so question number 6, should we bake light map even for PC games, or should we use real-time lighting? Now that's going to depend on what game you're using or what game you're making. If you're doing a mobile game and you want to make sure that you have really efficient use of the GPU, then what I would do is I would bake light maps, and I would have static lighting. Or you could even do things with vertex lighting. If you have small enough objects on the screen, you can actually use vertex lighting instead of dynamic lights or light maps. So each game that you work on is going to have a different requirement. Most likely any games that you'll be working on will probably have mixed light map and dynamic light information. So what happens with the mixed is that it'll pre-bake lights, but when the camera moves, it'll update the lighting inside that space. And if you just do baked lighting, and also what'll happen is that you'll get some really nice like GI contribution, global illumination contribution, so you get some nice bounces. But let's say you move your light from the side that was getting light, and you have that global illumination bounce, and you're getting light in the shadow space because it's got some nice white bounce off the ground. And if you move your light into where that side's in the shadow, it'll still be sort of light. So it entirely depends on the type of work that you're doing, what the game is, and that's going to be a conversation between you and a programmer as well. How much space do I have for light maps? How much space do I have for textures? How many polygons can I use? How many vertices for the character? Those sorts of things. Those are called metrics. And you need to understand the metrics of the game before you start building stuff for it. And so it's not a simple answer. It's really, it's as individual as the game that you're working on. Each game that I've worked on have had different means of using unwraps or using vertex lighting or using atlas textures or using individual textures or using lots of LODs or using no LODs. So each game is going to have a different function in how it reads that information. And as you work with your programmer, they're going to help you optimize. And there's some tools to help you optimize inside of Unreal and Unity. So looking at those two things, I think, will help out tremendously. Sorry, Drew. Okay, question number 7 is, should we learn Mel scripts as well? So, Mel script is for Maya, and it's really not useful for anything else. But if you learn Python, not only can you use that inside of Maya for its scripting, you can also use it in Unity, or you can use it in other engines, or you can use it for creating simple games, things of that nature. So Python is really a much better scripting language to learn than Mel. Mel is specific to Maya, but Python is actually used in Maya as well. So if you learn Python, you get more uses out of it than if you just learned how to use Mel specifically. So my recommendation is to use Python, and there's lots of games out there that are built in Python. RenPy is a free visual novel tool that is entirely constructed in Python, and the scripting is done in Python as well. So, and a lot of tools, programmers use Python rather than Mel. Okay, question number 8 is, what should be the skill sets of a technical artist? So that depends as well. I've seen technical artists that cannot program at all, but are excellent at understanding how game engines work. Even though they can't code themselves, they understand how it works. And so they're able to make some really smart decisions about tools and how they work and how they help the artist get more work done. Then you also have the other side of that, which is the highly technical artist who can program, and they may not be the best artist in the world, but they understand how the tools work and they can program themselves. So learning Python is going to be one of those skill sets that I was talking about before. The other one is creative problem solving, coming up with unique solutions to problems that no one else has ever thought of. And some examples of that, way back, we were working on a game, back 20 years ago, 20 years ago. We were working on this game, and we were building a post-apocalyptic Western. It never shipped, but we were using the Quake 3 engine. Well, Quake 3 doesn't do big open terrains, and the only tool that we had to work with was called BSP, binary space partitions, which is like a solid geometry. Pardon me. So one of the things that I did, as I was a level designer and artist, so I did both jobs. One of the things I did is that I started creating my buildings completely in 3D, low poly, snap together modular pieces with snap-on attachments with repeating textures. And I was able to build a wide variety of buildings using a small texture set and a small model set. And those models were basically just made out of a bunch of rectangles, a bunch of squares, planes. And we found that it was almost more efficient to run to render the models than it was the BSP in an open area. So, and when it started to get kind of expensive, we would have to partition off that area and make it visually out of the way, so we could portal it so it wouldn't draw while we were in another area. So we would basically have to do some tricks with area portals and um, optimization and like view frustum culling and things of that nature. But we came up with a really unique way of working with it, and we were able to do some really cool stuff prior to them closing down the production. But it was that creative problem solving, coming up with a unique answer to a difficult question. That's the biggest thing that a technical artist needs to know how to do. Okay, the next question is how do you decide the max poly count for a level? Again, these are metrics, and that's going to be helpful to discuss with a programmer. My inclination is to build what I want. So I just build out the level that I want, and then I start looking at optimization afterwards. So the very first thing I do is I build out an environment just out of BSP. It's called whiteboxing. I whitebox the environment. I see how well the environment is rendering at the time without anything in it. And then I start populating it with textures, and I check the optimization to make sure it's still functioning. And I'm getting like 60 frames a second or 90 frames a second or whatever the metric is that we're trying to hit. So at each step, I start adding models of various types. I start adding those in, and I do it in a way that's going to allow me to fall back. And what I mean by that is if there's a layer system in your game engine, you can put like detail objects on a detail layer. And that really works well. So for optimization purposes, let's say you're running on a high-end computer as a level designer, and I populate this area and it's running at 120 frames a second or whatever, even 60 frames a second, but I've got an RTX, I've got this RTX graphics card and it's just screaming fast. So that's great for me, but let's say somebody's got a GTX 980, right? GTX 980 Ti. They're not going to be able to have the same frame rate as somebody with an RTX card. So when you place objects in, you set them on different layers, and they're called fallbacks. So if somebody has a slower graphics card, those detail layers can be turned off. So it falls back to a lesser spec engine, which means it'll run faster on lower spec engines. So the other issue with trying to tell you poly counts is that there's different types of optimizations that happen with graphics cards. For instance, I could have a million, 300,000 polygon columns in a level, but that's only loaded into memory once, and then it's instanced around the place. So the graphics card only has to really understand the geometry of one of those. So it doesn't really care about the rest of them. It's just rendering those almost for free. I mean, there's obviously a cost for that many polygons on the scene, but it's less than it would be if it was 1,300,000 poly individual items that were all unique, right? You wouldn't be able to do that. So part of that optimization and understanding the max poly count is, again, those metrics that you have to talk to a programmer about, and you have to make sure that those things are in line. And they do so with, like real-time data collection tools while you're running in the game to see where the GPU is sitting, how many triangles are in the buffer, all that stuff. So there's a lot of things that are happening in the background. And if you're working with a robust engine, you should be able to pull up those metrics and figure out what's going on. So there's no real good answer for the max poly count. Apparently, according to the new Unreal 5 engine, it's unlimited. But I will be a what's the word I'm looking for here? I will hold my breath. Hopefully that will be the case, that I can just put ZBrush objects into the scene and not have to worry about it. But I don't think that's ever going to happen, at least not in my lifetime. All right. Okay, the next question is, should a 3D artist know shaders as well? Yes, that's the quickest way to answer that. So there's one thing that I will say, like I know people like using Marmoset tool bag or um, some other rendering tool to show their artwork. Um, as a game artist, the proof is always in the engine. So if you build something, I don't care what it looks like in Marmoset tool bag. I don't care what it looks like um, in the viewer in Substance Designer. What does it look like in engine? Does it look good in Unity? Does it look good in Unreal? Does it look good in the bespoke engine that you're using? And if it doesn't matter what it looks like in those tools because that's not how it's going to be seen eventually. So understanding shaders rather than just using Substance Designer and then making it look good for Sketchfab or something like that, or Toolbag, it's better to understand how to apply those shaders inside of an engine to get the actual results. So I would say yes, for sure, you need to understand how shaders work. Okay, the next question is, should a 3D artist know ZBrush? Absolutely. Um, it's not, it says, or is it an additional skill to have? I think there's two tools that are going to be um, growing more and more relevant. The first is Blender because it's free, because it's getting so much new tools in it. There's a cloth simulator that works really well. People are starting to work on something that's very similar to Marvelous Designer. Um, there's lots of free tools inside of Blender to help make your job easier. So that's the first one. The second one is ZBrush. That's becoming a package that you only have to use as well. So there are some people that never touch 3D Studio Max or Maya. Um, they can unwrap inside of ZBrush. They can hard surface model inside of ZBrush. They can texture inside of ZBrush. Um, so those are the two tools that I would say that you really need to start understanding and focusing on: ZBrush and Blender. Okay. So the next question is, what resources should I read to learn about lighting in games? So lighting in games and lighting in movies are very similar. My recommendation is to read a book called If It's Purple, Someone's Gonna Die. And it's a book about lighting, and it's specifically helps you understand how lights function, how they make people feel, what the best approach to lighting a scene is, that sort of thing. So that's a really good way to understand lights cinematically and how they function. The other thing I would look at, there's a guy named Clement Melendez. So what I'll do is I'll share my screen. Let me pull up his information first. Yeah, Clement Melendez. And he has an essay called Push and Pull. So let me just pull this up real quick. So he has this essay called Push and Pull. One of the things that he talks about is in influence via composition, lure with affordance. And some of the things that you look at in here, um, invite invite to take paths with higher affordance. So some things that are happening in here is that the lighting is playing a key role in people understanding how to navigate a space. And you can see this often, right? The lighting will always sort of guide the player. Attract attention with characters. Um, let's go back one. Influence via composition. Um, contrast, here we go. So color information is really good. part of lighting, understanding how to use lights, light and dark. These areas that draw your attention are something that you need to understand. Negative space, understanding how to frame things. Here with the negative space, framing stuff so they know where to go and what to do. So all of these things, you can see in every single one of these really great lighting that helps you understand what you're looking at. Lines and curves. See, all of these things, that lighting is super important. So I would read this article as well. You can see the address here, clementmelendez.com, portfolio articles, push-pull, and composition. Or just go to the push-pull here, and that will be all the information that you will need to understand about level design and how to push and pull the player through the environment. Let me stop sharing there. Okay, question 13 is, what should it be in a portfolio of a 3D artist when he or she applies for their first job? So I would say quality over quantity. I would be very specific with the things that I put in my portfolio. I'd want to make sure that I have the best quality objects that I've worked really hard on and remove any extraneous stuff. So my portfolio is a little bit different. I've been in the industry for 23 years. I've worked on a lot of different games. I'm also a traditional artist. So here, let me just show you this as well. So let's go back to screen share. And this is my portfolio in ArtStation. All right, let me share here. So I worked on a train sim. Um, I worked at Bungie for a little bit doing backgrounds. Um, I worked at Microsoft working on Shadowrun, doing environments. As a contract artist, working on some different projects, level layout and things of that nature. Showing off some modular pieces that I worked with in Unreal Engine 3 and the vegetation and stuff that I created. Worked on a Star Trek game a long time ago, doing vegetation and props and vehicles and things of that nature. But one of the biggest things that I did on that project was I helped with the terrain system. I also worked on Counter-Strike Condition Zero, doing vehicles and level design. Worked on the Lord of the Rings game that never shipped, working on props for that as well. So it's just a wide variety of things. I also do traditional props, miniatures, things of that nature. Also do sculpting, you'll see here, which is traditional sculpting. And some ZBrush stuff that I've done. And just some speed paints that I've done and things of that nature. So these are for demonstrations to show, working in different styles and things of that nature. But it's not a good portfolio to get a job. This is a driving game, Nocturne, Monster Truck Madness 2, Hellbender. So showing a wide variety of stuff for me is just showing my years of experience doing different things. Trying to get in the job in the industry, I would only try to do the very specific thing that I was working on. So if I wanted to be a vehicle artist, I would only show vehicles. If I wanted to be a character artist, I would only show characters. If I wanted to be a level designer, I would do level layouts and level write-ups and things of that nature. So whatever job you're interested in, that's the one that you would work on. Okay, so question 14 is, I cannot afford Maya, so I've been learning on Blender. If the company I joined uses Maya, is it difficult to make the switch? Yes and no. It's actually easier to make the switch from Blender to Maya than it is from Maya to Blender. It won't take very long. It's all hotkeys. You can print out a hotkey sheet and learn pretty quickly. The thing that's very similar to Blender is that there's tabs. There's a shelf inside of Maya that you work from, which is very similar to Blender's. And it's all exposed, so it's easy to get to. And there's also drop downs for mode switching between modeling and rendering and all that stuff. So again, very similar to Blender. There's just some quirkiness in terms of trying to get things to work. Sometimes Blender has some really good tools that make things easier, like simulations, like cloth and things of that nature, whereas Maya doesn't. Or it does, but pardon me, it does, but they're harder to use, and certainly not as quick. Okay, and the last question is how can an artist learn optimization while working on a video game? What are the different optimization techniques? So the biggest optimization technique is learning how to do LODs, or levels of detail. There are tools inside of Max and Maya that allow you to automatically optimize for LODs, and they're horrible. They don't work very well. So one of the biggest challenges, specifically, I'll just show you on this one, specifically on this game, the train simulator game, we had these consists of sometimes 300 locomotives, and these first pieces are 30,000 polygons exterior, 30,000 polygon exterior, 30,000 polygon interior. But when we were inside, we didn't draw the outside. So, and when we were outside, we had a really low resolution version of the inside one. So this one, if we had 30,000 polys all the way back 300 cars, well, that would be way too many polygons in the scene. So one of the optimizations is that we did really aggressive LODing, and specifically on cars that are white and smooth, there's a huge challenge there. So I can zoom in a little bit. So this is 30,000. This was maybe 5,000. This was maybe 300. This is maybe 150. So each progression down, we had far less information. And I believe I'm wrong. I believe it was only 3 steps. So we had high, medium, and low. Yep. And the way that that was approached is however close it was in the scene. So if it filled up most of the screen, it would, or a large portion of the screen, that would be the highest resolution. If it was a percentage lower than that, then it would lower resolution. And each time it became smaller, that resolution would go down. And it had a certain sticking point where it would do that. Same thing for buildings, same thing for track. Like you can see this track after a certain point. I mean, each one of these was a polygon inside of there. And so at a certain point, it turns into a texture, and then it fades away. You can see right there. It's called MIP mapping. When you lower the resolution of an object, that's called LOD. So that's one of the optimization techniques, is doing a really good job of LODing. The thing that you have to be careful of is that the texture will change as you LOD, and the lighting will change. How smooth something looks will change while you LOD. So if you can make it resemble the same smoothness from a distance, that's 90% of the work. And then what we used to do is we'd take this, let's say this large object here, we'd unwrap the entire thing, and I think it had several unwraps, because I think it was 3 unwraps for the exterior and 3 unwraps for the interior. But what we would do is we would do a side shot, a top shot, a front and a back, I believe. And then we would just lay that out in a box unwrap, but we'd make it really tiny on the texture sheet. And so we would just UV map that lower resolution down to that very small image on the very first sheet of the textures. And what would happen is that when it falls back, the textures that aren't being used, they just get unloaded or stored in a buffer. Whereas this would be actively, so basically just it prevented a lot of texture swapping while you were working, which is really good. Another optimization is, like I was saying before, portaling. Most of the optimization you're talking about is artists though. So artists, it would be LOD, it will be MIP mapping. So using the MIP mapping tools, the NVIDIA tools to do that correctly. Vertex lighting, learning about vertex lighting and unwrapping atlasing textures. That's another one that you should take a look at. And basically what that is you have a bunch of objects in the scene, and you run an atlasing program, and basically it does something very similar to, let's move this, let me stop sharing this. And let me start sharing this one. So if you look down here, this is an atlas. So but this is a light map atlas, obviously, but that's very similar. So yeah, so these are texture atlases. There you go. So basically it'll take all the textures and put it into one big one. So if you think about, let me just stop sharing again. Let's imagine that you have 100 1024 textures, let's say. And if you atlas them to a 4K texture, then you have to load in and swap in and out 4K textures, far less of them rather than doing 100 of them at a time. So that texture swapping also is an issue when it comes to optimization. So sometimes you'll do a really large atlas in order to save memory from doing the texture swaps really quickly. So that's another optimization. I guess it really depends on specifics of what you're trying to accomplish. Each game is unique, as I said before, and I think it's difficult to answer the question unless I know what the context of that is. So, but those are the sort of high-level LOD, MIP mapping, texture atlasing are the really big important ones. I think that's pretty much it. I really appreciate you sending me the questions. I look forward to hearing back from y'all if you have any more. And hopefully at some point we'll be able to do a live one and I can answer your questions straight away. Thanks.